Okay, here we are in lesson 3.5. This is going to be the last lesson in this chapter for you. So we are graphing linear inequalities in two variables. The key idea, right, is kind of giving you the step-by-step on what you will do. First, you will graph the boundary line, just like we graphed the linear equations in the last chapter. But you're going to use a dashed line if it's a less than or greater than, and you'll use a solid line if it is less than or equal to or greater than or equal to. Try to remember that this is similar to when you were graphing on the number line and you had an open circle or a closed circle. Now with the actual linear equation, the dashed line will represent that the solutions on the line are not part of the solution, okay? To be equal to them, they would be a solid line and be one of those symbols. Okay, so test a point that is not on the boundary line to determine if it is a solution. It's often easy and convenient to use the origin because we can easily substitute in zeros to tell this, unless it is part of the boundary line. Then, if the test point is a solution, shade the half plane that contains that point. If it is not a solution, that does not get shaded. All right, so the graph of a linear inequality in two variables shows all the solutions of the inequality on the coordinate plane. So that's represented here. This is y is less than 2x, all right? It says the boundary line divides the coordinate plane into two half planes, all right? The shaded part are all the solutions that make it true. The linear inequality in two variables, x and y, can be written in the following ways. We have the standard form, right? Less than or equal to, greater than or equal to. A, B, and C are going to be real numbers, and a solution is an ordered pair that makes it true. So here is the example from your book. It's also in your notes. The first thing is tell whether the ordered pair is a solution. So they're giving you the inequality, and then they're giving you the ordered pair, the x and the y. So you just substitute that in. Substitute in -1 for x, 9 for y. Simplify. You get 7 less than -3. Is it true? No, it's not true. Therefore, -1, 9 is not a solution to the inequality. It would be on the half plane that is not shaded. When we are graphing, we want to graph the inequality just like we graphed the linear equation. So you can see that we're graphing the line y is equal to 2, but we're going to use a dashed or dotted line depending on the symbol. This means solid. I said dashed or dotted. Solid or dotted or dashed or whatever line. So this is going to be a solid line. So we have this line right here, right, at 2. And then we test, for instance, the origin 0, 0. So is 0, substituting that in for y, less than or equal to 2? Yeah, it is. So because it is, we could shade in that whole half plane, okay? So we want to tell whether the ordered pair is a solution of the inequality. So for number 1, we have, we'll substitute in -2 plus 2 greater than 0. So is 0 greater than 0? Absolutely not. It is not greater than. It is equal to. So had this been a different symbol, we could have said yes, but it is not greater than. For number 2, we are testing or checking the origin. So number 2, we would take 4 times 0 minus 0, right? That's y as well. Has to be greater than or equal to 5. So is 0 greater than or equal to 5? Again, no. All right. Change colors over here for 3. We have 5 times the -4 minus the 2 times -1 less than or equal to -1. So I'm just substituting in the x and the y. -20 plus 2 less than or equal to -1. -18 less than or equal to -1. Yes, this is true. And number 4, -2 times 5 minus 3 times negative 7 has to be less than 15. So it is negative 10 plus 21 less than 15. We end up with 11 less than 15. And yes, that is also true. All right, ready to clear and move on. Okay. For number 5, all right, we are going to graph these. Hold on here. I'm going to move myself back down to the corner. Grab the pen. Okay, so we want to graph it as if it is y is equal to negative 1. So we'll start here. And then decide from the symbol dashed or solid. And this one's going to be dashed in both directions, horizontal line. Okay, for number 5. Then we want to test, say, the origin, right? So there's no x, but we can put in a 0 for the y and see if y is greater, or 0, sorry, is greater than negative 1. And since 0 is greater than 1, negative 1, we would be shading the half plane that includes the origin. And I'm only going to shade like this, okay? If you're doing this, hopefully we'd be doing one per graph, and you would shade in the entire half plane. But since we're going to be doing all 4 on this one graph in your notes, I don't want it to be too confusing. But I will be changing colors here for you. So number 6, we have another horizontal line, and this time y is greater than or equal to negative 5. So it's going to be a horizontal line at negative 5. So negative 1, 2, 3, 4, negative 5. And then this symbol tells us we want a solid line. Okay. As straight as I could possibly make it. For number 6, I'm just kind of numbering it. And then we'll test, we can test the origin again. 0 greater than or equal to negative 5? Yes, it is. So again, this would be shaded up. So notice I have not made them overlap. But typically, this would cover in the entire thing. Okay, number 7. Now we have a vertical line, and x is less than or equal to negative 4. So 1, 2, 3, 4. And it's going to be a solid line. So we want a solid line right here at x is equal to negative 4. And that's number 7. Let's test the origin. So again, the x-coordinate would be 0. Is 0 less than negative 4? It is not less than negative 4. And so if it's not less than negative 4, that means that this right-hand side is not shaded. So we want to shade the left-hand side. Okay. Again, you would be shading the entire plane. Okay. Finally, we'll do number 8. 3.5 is greater than x. So this is telling us a dashed line at 3.5. So 1, 2, 3.5 would be halfway through. So we want a dashed line. That is vertical. And that'll be number 8. All right, is 3.5 greater than 0? Because we're testing the origin. Would I graph on this side? 3.5 is greater than 0, so that means that the origin would be shaded. So I want to, again, shade this left half plane. And again, we would shade the whole thing. Okay, so maybe you want to use some colored pencils if you have to, do this in your own notes so that you can kind of test and see, but I'm going to go ahead and clear this out. If you need to pause the video. All right. Let's go ahead and do this. I know we haven't done a lot of these, but it'll help with doing a word problem for when you're working on your homework. So it says you can spend at most $24 on party supplies. Party hats cost 50 cents each. Helium balloons cost $2 each. We want to write and graph the inequality to see the amounts of hats and balloons we can buy, and we want to identify maybe two solutions. So first of all, we're going to have to identify what is X going to be and what is Y going to be equal to. So, X can be the number of hats, and Y can be balloons, right? Then we want to use this amount, so 0.50 times party hats cost this much, so this is X plus 2Y, and if it's going to be at most, right, at most 24, that can be the biggest number. It can be equal to 24, but it can also be less than 24, so less than or equal to 24. So if we're going to graph it, and there's not a graph here, but I can draw one. Couple different ways we could do that. We could do using intercepts, right? We could say, well, if we're going to do the x-intercept and the y-intercept, with the x-intercept, we're going to do 0.5x less than equal to 24. So we'll get x is less than or equal to, we'll divide 24 by half, right? Or basically times it by 2. So 48. And the y-intercept is going to be 2y is less than or equal to 24. Dividing it by 2, y is less than or equal to 12. Sorry. All right, so if I graph it, let's count by 8, 16, 24, 32. We have 40, 48, and then we would have 56, 64. Okay, and then we can count by twos. Okay, so graphing would look like this because y is equal to 12 and x is equal to 48, and it would be a solid line because of our symbol. So we can connect that. Okay, now we want to test anything, right? We want to test, we could do the origin. So we would say, if this is 0 and this is 0, is 0 less than or equal to 24? The answer is yes. So that makes this whole thing, right, shaded in. Okay, so all of it, that's what it is. So we would have to identify some ordered pairs here. So let's say we want to do like 8 and 4, right? Here's a solution, 8, comma, 4. So that's the x and the y. So we could test it out. We could do like 0.50 times 8 plus 2 times 4 to be less than or equal to 24. So half of 8 is 4 plus 8 less than or equal to 24. So is 12 less than or equal to 24? We already know the answer is true, right? But what does this mean? What is the interpretation of this ordered pair? Well, it means we could have 8 hats and 4 of the helium balloons. Okay. It wanted us to identify another one, right? What if we did 32 and 2. So the ordered pair of 32 and 2 means we could have 32 hats and 2 balloons. Okay. And we probably have money left over because it's, down here. Anything graphed on the line means we probably wouldn't have any money left over at the end. So I'm going to go ahead and clear this. If you want to go ahead and take the time to write it down or think about it or see if you have any questions about it. All right. So now we're going to do some of the extra practice with the graphing. And you can, like in this case, right, the coefficient is 1. So we already know that the x-intercept is less than or equal to -4, and the y-intercept is less than or equal to -4. So we could graph those 2 points, 1, 2, 3, 4. 1, 2, 3, 4. And then because of this symbol, we know that it's going to be a solid line. I'll do my best. Ooh, it's not a great line. All right. Well, what if we test the origin, right? 0 and 0. Is 0 less than or equal to -4? No. So that means that this side is not shaded in, but this side is. Okay, so you'd be shading in this side because the origin was not included. Okay, here, it's going to give us the x and y intercept as 0, so we're going to have to put it in slope-intercept form. So minus x, -2y, less than -x, divide by a -2, and we will get y is greater than, don't forget, if you're dividing by a negative, you're reversing the symbol, and that's going to be a positive 1/2 x. So here, and then we'd go up 1 over 2, up 1 over 2, and we could go down 1, back 2, down 1, back 2, and it's going to be a dashed line. Okay, so those kind of look like dashes anyway, don't they? So we'll let it maybe look like that. Okay, so here's our dashed line. It's on the origin, so we want to pick up and maybe do something else. So let's just go over here and do maybe like 2, -2. Let's test that point right there. So if we have, we're trying over here, is -2 greater than half of 2? Basically, we're saying is -2 greater than 1? And the answer is no. So down here is not shaded in. Does that make sense? So we want to shade in then this part of the plane. Okay, sorry that my work kind of got on the graph. Okay, looking at number 11. Number 11, again, want to go ahead and put it in slope-intercept form. So we have 2y greater than or equal to -2x plus 3. Then we're dividing everything by 2 to get y is greater than or equal to a -x plus 3 over 2. So we have, let's see, from here we want to start with 1.5. Yeah, that's a bad. Let's see if I can erase that little dot. All right. 1.5. Beep. Okay. And it's a negative slope, so we would go down 1 and over 1, down 1 and over 1. So it's all going to be, or up 1 and over 1, up 1 and over 1. It's going to be a solid line this time. Ooh, look at that. Okay. Let's finish drawing it a little bit more. Okay. Now we can try 0, 0, right? Is 0 greater than or equal to 3 over 2? Right? Is it greater than or equal to 3 over 2? No. So we want to go ahead and graph this half of the plane that does not include the origin, because that was not true. Okay. If you have any questions, I'm about ready to clear. So we're time of the video to do your vocabulary and check. You have 4 to choose from. Make sure that you are answering and numbering which one you are answering. And then it also says match the inequality with its graph. So I will put this question on there as well. I'll find a way to word it so that you can, maybe it'll be an open response and you can tell me, 5 is equal to which letter, 6 is equal to which letter, and 7 is equal to which letter. Or actually, maybe we'll just save this one and do it on big ideas. So we'll do the vocabulary and check. Here we go. It says, the best portion of a man's life, his little, nameless, unremembered acts of kindness and love. That's a very nice statement. So I'll see you in class tomorrow. Make sure that you let me know if you have any questions. Take care.